Welcome to my channel. This is Krishna Swami. So in our course, our first chapter name is units and measurements. Already we learnt about the concepts of what are the physical quantities and types of physical quantities, and next one is the system of units, and also we discussed about the what are the concept of dimensions, and in our previous classes we solved the some mechanical dimensions and some non-mechanical dimensions. So in this our non-mechanical dimensions, already we have to discuss about the dimensions of our concept is electricity, and also we discussed about the dimensions of the dimensions of physical quantities in thermodynamics. So in this class we want to discuss about or solve the dimensions of magnetism, and also we have to discuss about the dimensions of physical quantities in optics. Okay, now we will discuss about the dimensions of magnetism. So what are there? Magnetism. So in this magnetism we want to solve the dimensions of the following physical quantities. So what are there? So we can see one by one. So first one is magnetic flux. Magnetic flux. And second one is magnetic induction or magnetic induction or magnetic field strength. Magnetic field strength denoted by B. This flux denoted by phi or d phi. Okay, now next one is so magnetic flux, magnetic induction, and next one is magnetic dipole moment. Magnetic dipole moment. Magnetic dipole moment. So it is denoted by capital M. So next one is, next physical quantity is pole strength, magnetic pole strength. Magnetic pole strength. Magnetic pole strength, it is denoted by small m. So next one is self inductance. Self inductance. And also we want to write the dimensions of the mutual inductance. Mutual inductance. And also we want to write about the dimensions of so mutual inductance, self inductance, and next one is magnetic intensity. Magnetic field intensity. Magnetic field intensity denoted by capital H. And also we want to write the dimensions of magnetic permeability. Magnetic permeability. magnetic permeability. Now we want to write the dimensions of these physical quantities one by one. So first one is magnetic flux. So how we can write the dimensions of a magnetic flux? So magnetic flux, okay, d pi. Already we know about the equation of the magnetic flux, that equal to E equal to, that means EMF or electric potential equal to d pi by dt. So now we can write it as the dimensions of a d phi. So we want to d phi, that means so d phi equal to E dot dt it will become. So now we want to write the, what is E? E is a EMF or electric potential. So that means already we know the EMF or the dimensions of a EMF or electric potential is, so E equal to work for unit charge. So already we know these dimensions. E equal to, what are the dimensions of work? M1, L2, T minus 2 by 80. So these are the dimensions of a E. Now we can write it as the dimensions of d phi equal to, so in this E place we can write the dimensions of the E. M1, L2, T minus 2 by 80. So here this dt is a dimension of time t. So that can be written as t. Now here this time t and this time t both are get cancel. Both are get cancel. So that equal to, that means so the magnetic flux d phi equal to M1 L2 T minus 2, and here ampere E minus 1. Therefore the dimensions of a magnetic flux is M1 L2 T minus 2 and A minus 1. So A means ampere. So what are the units of magnetic flux? So units of magnetic flux is Weber. So Weber, it is a units of magnetic flux. Now we can observe these dimension. So it can be dimension of the work. So simply we say that work or energy, so work for current. We can also units of this magnetic flux is joule for ampere. Joule for ampere. So if you know these units of magnetic flux, joule for ampere, you can write it as directly. So what are the joule? Joule is a worker energy unit of. So now we can write directly M1 L2 T minus 2 for ampere. So simply you know this unit, you can write it as easily the dimensions of a magnetic flux. So these are the dimensions of the magnetic flux. So next one is magnetic Next one is magnetic inductance, self inductance. Magnetic self inductance or self inductance. Self inductance. So it is denoted by some letter L. So we know the equation of a self inductance is, so E equal to L into di by dt. So now we want to the dimensions of the self inductance L. So that means L equal to E into dt by di. Already we know the dimensions of the small g or EMF is E equal to, so M1 L2 T minus 2 by AT. So now we can substitute this E value in this equation directly. So that implies, so the self inductance L equal to, in this place, M1 L2 T minus 2 by AT into, here T is a dimensions of time and I is a dimensions of current. So we can write it as T by, so dimensions of current is I. Here T get cancel. So that implies self inductance is equal to, the dimensions of self inductance equal to M1 L2 T minus 2, here A into A square. So when the A square becomes the numerator, the value of exponent is minus 2. So therefore the dimensions of a self inductance is M1 L2 T minus 2 and A minus 2. Here clearly you can observe these dimension. So this is a dimension of work or energy and A is a dimension of current. So simply we can write it as, so units of self inductance is, so joule for ampere square. Joule for ampere square. So what are the units is it? So these units of inductance is Henry. So if you know these units, you can write it as the dimensions of self inductance is directly. You can know the dimensions of joule. So joule means the dimensions of energy or work. So and you know the ampere. So ampere means dimension of current. So we want to know this units of self inductance. We can directly write it as this, its units. Okay, now we want to know the another physical quantity, mutual inductance. So mutual inductance. Next one is mutual inductance. Mutual inductance denoted by M, some letter M. Here also same. Here also we use the same formula, E equal to mutual inductance M, so di by dt. Here we want to write the dimensions of mutual inductance. So that means M equal to E dt by di. Already we know the dimensions of EMF. So that equal to, that means E means, so work for charge into dt by di. Now we can write it as its dimensions. We know the dimensions of work, m1 L2 t minus 2 by the dimensions of charge is a t, and dimensions of time is t, dimensions of current is ampere a. Now t get cancelled, so that equal to m1 L2 t minus 2 a minus 2. Same, the self inductance and mutual inductance have a same units and same dimensional formula. So therefore units of self inductance or mutual inductance is Henry units. So the fundamental units of this mutual inductance is joule for ampere square, joule for ampere square. Next we want to write about the dimensions of a magnetic induction or magnetic field strength, magnetic induction or magnetic field strength. So now we want to write the dimensions of a magnetic induction or magnetic field strength, magnetic field strength. It can be also called as a magnetic flux density also, magnetic flux density also. Now we can write the, already we know about the our magnetic field strength. So force equal to, from formula BVQ, here B is, here F is force, B is magnetic field strength, V is velocity, and Q is charge. Now we want to write about the magnetic field strength, the dimensions of magnetic field strength. B equal to force by velocity into charge. Already we know about the dimensions of a force. What are there? M1, so L1 t minus 2, and we know the dimensions of velocity. What are there? So what are the units of velocity? Meter per second. So therefore here m is 0, so m0 meter L1 per second t minus 1 into, already we know about the units, dimensions of the charge. So what are the dimensions of charge? Small q equal to it, so time, current into time, that means, so current into time. Okay, now we can write it as this equation. So L1 is get cancel, so m1 t minus 1, so becomes the plus 1, here t minus 1, and this t becomes also minus 1. So L0 t minus 2 and a minus 1. So these are the units, the dimensions of a magnetic field strength. Next, what are the units of a magnetic field strength? So units of magnetic field strength is Tesla. So units of magnetic field is Tesla. Next, we want to write about the dimensions of a magnetic dipole moment. So magnetic dipole moment, magnetic dipole moment. So capital M denoted by the magnetic dipole moment. According to the definition of the magnetic dipole moment is M equal to current I into area A. So already we know about the dimensions of the current. Dimensions of the current is ampere, and also the dimensions of the area. Area means meter square. Units of area means meter square. That means L to the power of 2 or L2. So that means A L2. So therefore the dimensions of a magnetic dipole moment is AL2. So what are the units of magnetic dipole moment? Here A means ampere. So L2 means meter square. Ampere meter square. So these are the units of magnetic dipole moment. If you know about these unit of magnetic dipole moment is ampere meter square, you can write it as directly the dimensions of this magnetic dipole moment. Ampere means A and meter square means L2, length. It denotes the length. So this is a simple technique of the writing of a dimensions. So next one is, next we want to write about the dimensions of a magnetic pole strength. Dimensions of magnetic pole strength. Magnetic pole strength written as small m. So according to the definition of a magnetic pole strength M, small m equal to, so magnetic dipole moment by 2L. So already we know about the dimensions of the magnetic dipole moment is AL2. So already we know about the rules of the writing of a dimensions. So the numericals can be neglected. 2 is neglected, but dimensions of length is L by L. So 1L get cancelled. Therefore the dimensions of the magnetic pole strength is AL. So what are the units of magnetic pole strength is, A means ampere, L is measured in length. So the units of length is meter. Simply we can write it as ampere meter. So if you know this unit of a magnetic pole strength, you can directly write it as its dimension easily. Okay, next one is, so magnetic pole strength, magnetic field intensity. So next we want to write about the dimensions of a magnetic field intensity. According to our Biot-Savart law, mu naught by 4 pi into ideal sin theta by r square. So here dB equal to mu naught h. Now we want to write about the dimensions of the magnetic field intensity h. So h equal to ideal sin theta by r square here. So already we know about the rules of a, according to the rules of the dimensions, there are there are numericals and trigonometric values, and some values are neglected. So when we write the dimensions, so it can be written as ideal by r square. So here I means the dimensions of current, dl means dimensions of length, so r also dimensions of length. So now we can write it as EL by L square. So here 1L get cancel. So therefore the dimensions of the magnetic field intensity is, so E, therefore the dimensions of the magnetic field intensity is AL minus 1, AL minus 1. So the units of the magnetic field intensity is ampere for meter, ampere for meter. So these are the units of the magnetic field intensity. So simply you know the units of magnetic field intensity, that is ampere per meter. So you can directly write it as its dimensions. So ampere means I, current, and m, meter means length. So you can write it as simply A L minus 1. So these are the simple technique of the writing of the dimensions of physical quantities. So next one is magnetic permeability. So next we want to write about the dimensions of a magnetic permeability. So magnetic permeability. That is mu. According to Coulomb's magnetic force, so magnetic force law, according to Coulomb's law in magnetism, here F equal to Coulomb's force in magnetism, F equal to mu naught by 4 pi m1 m2 by r square. Now we want to know the dimensions of a magnetic permeability. So here we want to write it as mu naught. So 4 pi, it is a numerical value, so it can be neglected according to our dimensional rules. So mu naught equal to F into r square by m1 m2. Here F is force, so r is distance, and m1 comma m2 are the magnetic pole strengths. So magnetic pole strengths, magnetic pole strengths. Okay, now already we know about the dimensions of the force, that is m1 l1 t minus 2 into dimensions of length. So here meter square, that means L2. So length is L2. So already we know about the dimensions of a magnetic pole strength is AL. So ampere meter. So here m1 is AL and m2 also can be written as AL. So this equal to m1 L1 t minus 2 L2 by A2 L2. Here we can L2 get cancel. So that means m1 L1 t minus 2. So here a minus 2. Therefore the dimensions of a magnetic permeability is m1 L1 t minus 2 and a minus 2. So you can observe this dimensional formula. So this is a formula of a force, dimensional formula of a force. So here units, so we can write it as its fundamental units is Newton. Force is measured in Newton for ampere square. So Newton for ampere square. So these are the fundamental units of this magnetic permeability. If you know about this unit of a magnetic permeability, you can directly write it as its dimensional formula. So N, Newton. So what are the dimensional formula of Newton? M1 L1 T minus 2 for ampere square. So A to the A minus 2. So these are this can be written as simply the dimensions of the magnetic permeability, or units of this magnetic permeability is this. So these are the units of these are the some of the dimensions of physical quantities in magnetism. Now we want to write about the dimensions of physical quantities in optics. So optics lo chuddam. Optics. So in this optics, so we can write some dimensions of physical quantities in optics. So first one is luminous flux. Luminous flux, dimensions of luminous flux. So second one is dimensions of brightness. Illuminance or brightness, dimensions of brightness or illuminance. So next one is the dimensions of luminous intensity. Luminous intensity. Next, the dimensions of power of lens. Power of lens. And also we can write it as some dimensional formula of decay constant. Decay constant. So decay constant. Here we can write it as first of all, so the dimensions of luminous flux. Luminous flux. So it means the light emitted per second is called as luminous flux. So visible light emitted per second. So that means the energy for time. So already we know about the dimensions of energy is M1 L2 T minus 2 by T. Here denominator T power 1, it becomes the minus 1 in numerator. So that means the dimensions of a luminous flux is M1 L2 T minus 3. So these are the dimensions of a luminous flux or luminous power So simply already we know about the dimensions of a flux is M1 L2 T minus 3. So simply we can write it as this. So units of this luminous flux is watts. So if you know the unit of the luminous flux is watt, you can directly write it as the dimensions of a power is M1 L2 T minus 3. So next one is brightness or illuminance. So brightness. So the dimensions of a brightness or illuminance is, it can be defined as the luminous flux from unit area. Luminous flux from unit area is called as a brightness. So it can be written as a luminous flux for unit area. So luminous flux for unit area. So already we know the dimensions of a luminous flux. Luminous flux or luminous power is m1 L2 T minus 3. So and also we already know about the dimensions of a area. So what are the units of area? Units of area is meter square. That means the length is 2 L2. So this implies so the brightness, the dimensions of brightness is luminous flux. Dimensions of luminous flux is m1 L2 T minus 3 by area is L2. So here L2 get cancelled. So therefore the dimensions of a illuminance or brightness is m1 L0 T minus 3. So the units of a luminous or illuminance is, the units of illuminance is Lambert. So here what the units of a luminous flux is what are lumen. So lumen. Units of luminous flux or power is lumen and units of brightness or illuminance is Lambert. Now we want to write about the dimensions of a luminous intensity. Luminous intensity. Luminous intensity. So now we can write it as a, according to the definition of a luminous intensity is the luminous flux for luminous flux on unit area is called as a luminous intensity. So simply you can write it as luminous flux by unit area. So already we know about the dimensions of a luminous flux is m1 L2 T minus T 3 and also the unit area, dimensions of unit area is L2 will get cancelled. Therefore the dimensions of a luminous intensity is m1 L0 T minus 3. So the dimensions of a luminous intensity and also the dimensions of a illumination or brightness are also same, but units of a luminous intensity is lux. The units of a luminous intensity is lux, Lux. So Lux. Now we can write the dimensions of a power of lens. Dimensions of power of lens. The power of lens. Power of lens. So according to our definition, already we know about the formula of a power of lens is, that is 1 by focal length f. So length is measured in meters. That means the dimensions of length is L1. Here the length is in a denominator. When the length becomes a numerator, its value is -1. So now simply the dimensions of power of lens is focal length inverse. That means L minus 1. So these are the, so it can be written as m0 l minus 1 t 0. These are the dimensions of a power of lens. So what are the unit of power of lens is diopter. The units of power of lens is diopter or meter inverse. So next we want to write about the dimensions of a decay constant. So decay constant. So already we know about the decay constant is 0.693 by half-life. Here half-life is a time. It indicates the time. So that means 0.693 by t. So now we also know about our rules of a dimensions. We can neglect the numerical values and trigonometrical values and etc. So now we can write the dimensions of a decay constant is t power minus 1. So t minus 1. So these are the dimensions of decay constant. So what is the units of decay constant is 1 by second or second inverse. So these are the some dimensions of the magnetism and also optics. ఓకే, సో ఈ విధంగా మనం డైమెన్షన్స్ అనేది రాసుకోవడం జరుగుతుంది. మరి డైమెన్షన్స్ ఈ ఫార్ములాస్ ఇవన్నీ ఏం గుర్తుండట్లేదు, మాకు ఇబ్బంది అవుతుందంటే మనకి ముఖ్యంగా ఒక 3 డైమెన్షన్స్ అనేది గుర్తుంచుకోవడం వల్ల మిగిలిన ఈజీగా రాయడానికి వీలవుతుంది. సో మరి ఆ 3 డైమెన్షన్స్ ఏవి గుర్తుంచుకోవాలని చూద్దాం. సో మెయిన్గా మనకి 3 డైమెన్షన్స్ అనేది వస్తే మిగిలినవి వాటి నుండి రాసుకోవచ్చు. సో ఇంపార్టెంట్ డైమెన్షన్స్, దెర్ ఆర్ ఏ డైమెన్షన్స్ ఆఫ్ ఫోర్స్. డైమెన్షన్స్ ఆఫ్ ఫోర్స్ ఈజ్ ఏ m1 l1 t minus 2 and dimensions of work or energy, that is m1 l2 t minus 2 and also dimensions of power. So m1 l2 t minus 3. సో ఈ 3 డైమెన్షన్స్ అనేది మనకు తెలిసినప్పుడు మిగిలినవి ఈజీగా రాసుకోవడానికి వీలవుతుంది. సో వాటి యొక్క యూనిట్స్ అనేది మనకు డైరెక్ట్గా ఫండమెంటల్ యూనిట్స్ అనేది ఫైండ్ అవుట్ చేసినప్పుడు ఈజీగా రాసుకోవడానికి వీలవుతుంది. ఫర్ ఎగ్జాంపుల్ రెసిస్టెన్స్. సో డైమెన్షన్స్ ఆఫ్ రెసిస్టెన్స్ తీసుకున్నప్పుడు మనకి దాని యొక్క ఫార్ములా R ఈక్వల్ టు P బై I స్క్వేర్ అనే ఫార్ములా. సో హియర్ P ఈజ్ ఏ power, I is a current. So what are the dimensions of power? m1 l2 t minus 3. సో సింపుల్గా మనం ఏం రాసుకోవచ్చు ఇక్కడ. సో ద డైమెన్షన్స్ ఆఫ్ రెసిస్టెన్స్ అడిగినప్పుడు పవర్ m1 l2 t minus 3 by ampere square, that means a2. So it can be written as simply m1 l2 t minus 3 and a minus 2. సో ఈ విధంగా మనకు పవర్ అనేది తెలిసినప్పుడు డైరెక్ట్ మనం రాసుకోవడం జరుగుతుంది. సో ఇదే విధంగా ఇంతకుముందు మనము మ్యాగ్నటిజంలో కూడా రాయడం జరిగింది. సో యూనిట్స్ అనేది మనకు బేసిక్ యూనిట్స్ తెలిసినప్పుడు వీటిని యూటిలైజ్ చేసుకొని మనం డైమెన్షన్స్ అనేది ఈజీగా డిరైవ్ చేసుకోవడం జరుగుతుంది. సో దీంతో మనకున్న డైమెన్షన్స్ అనేది దాదాపుగా ఎక్స్ప్లెయిన్ చేయడం జరిగింది. సో నెక్స్ట్ క్లాసెస్లో మనకి ప్రీవియస్ ఎగ్జామ్లో డైమెన్షన్స్పై అడిగిన క్వశ్చన్స్ ఏ విధంగా ఉన్నవి, అవి ఏ విధంగా సాల్వ్ చేయాలో అనే దానిపైన ఫోకస్ చేస్తే సరిపోతుంది. సో ఓకే, థ్యాంక్ యూ ఫర్ watching. If you like this lecture, you can like my channel and also subscribe my channel.